Hi everyone. Today I have a very, very interesting guest with me. This is PD Mangan. He's educated in the field of pharmacology, biochemistry, microbiology, and he also has a YouTube channel and a webpage called Rogue Health Fitness if you're interested in checking them out after this video. So the reason that I wanted to have him on here is actually because he's written a book, or actually has written several books that you might be interested in. One is called Stop the Clock, the Optimal Anti-Aging Strategy. And also for you guys, Best Supplements for Men, More Muscle, Higher Testosterone, Longer Life and Better Looks. And the reason that I wanted him on is the book Dumping Iron, How to Ditch the Secret Killer and Reclaim Your Health. And there are several other books. I'm not going to just read the whole list out, but you can check it out on Amazon, I guess. So the last book, as I mentioned, is also the reason that he's here today. And we want to talk about iron overload, how it relates to insulin resistance, and also whether we need to be wary of eating too much red meat. So welcome to the show, PD.
Thanks, Pim. Thanks very much. It's my pleasure to be here. Thanks for inviting me.
Thank you very much. So before we get into the questions, I'm just wondering if you could just briefly explain what ferritin is and how it relates to iron and what we can conclude from a very simple lab test.
Okay, sure. So iron is required by all living beings from bacteria on up, and it is a very reactive metal. Hence, as you can see by the fact that iron will rust when exposed to oxygen and water, and it reacts with many, many different things. And so for that reason, when living things take in iron, they use different mechanisms to segregate it, to separate it from the rest of from other cells, from other reactants, proteins, and so on. And the molecule used in mammals is something called ferritin. So ferritin is a protein, and it holds iron in its core, up to something like 5,000 iron atoms can be held inside the core of a ferritin molecule, and so it keeps it from reacting with other things, and then it can be used when needed. So when we look at iron inside the body, we often look at ferritin. So, like you say, this is a simple lab test, and ferritin is the best measure of stored body iron. There are other measures such as iron and total iron binding capacity, transferrin saturation, and so on. You often see those, and some older studies have used those to get a measure of how much iron is in the body. But ferritin is actually the best measure. Let me add something else, that ferritin is also can rise in inflammatory situations, right? So somebody with a serious acute illness can have very high levels of ferritin. So this is not necessarily reflective of stored body iron, but in most, the vast majority of reasonably healthy people, ferritin is the best measure of stored body iron.
Okay. So just out of interest, because we discussed this a little bit before I actually pressed the record button, but what got you interested in this particular area of research? Because it's not something that is talked about, so you must have come across something that piqued your interest.
Right. So I'm interested in health and fitness in general, and write about it, and have been for a long time. As I was mentioning to you, long time ago, in the Wall Street Journal, there was an article about a man, Dr. Jerome Sullivan, who was a pathologist, and he was the first one to hypothesize that there might be a link between iron and heart disease. And that was way back a long time ago. I remember reading that, found it very interesting. And then fast forward a few decades, and I came across something and started delving into it, wrote a number of articles about it, about iron and health for my website. And when I had written so much, I had realized that not very many people had heard of this topic, and that it was worthwhile to write a book about. And so I did, and I tried to put it in. I tried to explain things as simply as I could, because I realized there was a lot of biochemistry and cell biology going on. I happen to find a lot of this fascinating, but most people aren't terribly interested in all that. So I just tried to explain in the most basic ways how why high iron was important, and how it can lead to ill health and disease.
Well, okay, so we all know that iron overload, that's a real condition. Usually we're thinking about hemochromatosis when we are thinking about that. But what you're talking about is actually something that isn't classified as iron overload. And these levels are actually normal, or the ferritin levels that you measure are within the normal range. So if we're using the medical reference ranges that most labs actually do, is there a way to tell whether there's a problem? Where should we draw the line?
Yeah, this is a very good question, because as I started delving into the research and writing about it, I realized that what we think of, or what laboratories tell us are normal ferritin levels, that they aren't really normal. And also, just for the benefit of your viewers here, every time I say ferritin, you could just mentally substitute iron. But so ferritin is just the way we measure it. So in hemochromatosis is a genetic disease in which people take in too much iron, and it accumulates over a relatively long period of time, and they get very high iron in their bodies. So, for example, somebody who had hemochromatosis and had it for a while. Well, of course, it's genetic, so it's lifelong, but generally it's not till, say, early middle age that somebody will have accumulated a huge amount of iron. But someone with hemochromatosis might have a ferritin level of well over 1,000, and over 2,000, even higher. And so when a doctor sees that, he knows that there's something quite wrong there. And there is genetic testing available today to see whether somebody, really does have hemochromatosis, or if they had a borderline high ferritin, whether, what was the cause of this, whether it's hemochromatosis or something else. People do get very high iron overload for other reasons too. For example, there are people who need regular transfusions, and if they get these regular transfusions over a long period of time, they get iron overload. But for normal, healthy people, laboratories will give a normal range of ferritin of, the numbers differ between men and women, but generally speaking, somewhere in the range of 30 up to 300, 400, even 500 is considered normal by laboratory. So if you went to a doctor, he ordered a ferritin lab test, which is not uncommon, and it came back, let's say 300 or 250. Let's say 250. Because that will cover most cases. They won't. The doctor will not normally give it a second glance, because that's considered totally normal. Yet the evidence shows that there is higher health risk at a ferritin level of 250. So this is one reason why it's important for people to be aware of this, because frankly, most doctors are not. And there can be cases of more or less subtle problems that people have without an astronomically high ferritin, but the ferritin is related. To try and decide what truly is a normal ferritin level, there's various research that can be looked at. A couple of years ago, I think it's been already, Dr. Leo Zakarsky, who I talked to when I was writing my book, and who is one of the world's foremost experts on iron and disease. He is a medical professor at Dartmouth University in the United States. He came to the conclusion that a ferritin of over 100 was associated with disease. So beginning at the level of 100, you could see, this is observational, of course, but you could see that people had more disease beginning at that ferritin level. So the conclusion would be, if you wanted to be in optimal health, your ferritin level should be no higher than 100.
So what you mentioned subtle signs and symptoms. What are we looking for?
Well, if it would be nothing, that unusual, but if somebody had some degree of metabolic dysfunction, for example, insulin resistance, if some older person was perhaps having cognitive impairment, things like that. I have talked to people who had various problems, fatigue, for example, with, and their ferritin was in the 250 to 300 range. And when they get it down, they feel a whole lot better. When you're talking somewhat higher levels, you're definitely talking about, for example, there's a study that I included in my book about gout. So this was interesting because the evidence about iron and disease is comprised of, it has various parts. So there's observational or epidemiological evidence, which of course cannot prove causation, but there are a number of experimental studies, randomized controlled trials, and so on, dealing with iron reduction. So one of these had to do with gout. And they just took a bunch of people with gout and phlebotomized them regularly over a period of, I believe it was a year, and followed them for a couple of years to see what happened. And they got them down to what the main author of the paper described as near iron deficiency. So they got ferritin levels quite low, down into about the level of 20, I believe. And in any case, their gout attacks declined sharply. Something like an 80 to 90% decline in the frequency and the number of gout attacks. So that is, there's one example. If somebody was having gout, then, ferritin might be involved in that. Generally what you find that metabolic dysfunction, seems to go hand in hand. So with high iron. So what happens is, or what seems to happen is, I say this because this all gets enormously complicated. There is lots of unknown. There are a lot of unknowns here. But people with metabolic syndrome tend to have higher iron levels. So what appears to happen is, metabolic dysfunction also makes dysfunctional the iron absorption mechanism in the body. And then the reaction of this iron with other elements, such as omega-6 fatty acids, that is a very good candidate there, leads to fatty liver and excess visceral fat and this sort of thing. So there's always a question about, what comes first? Is it the high iron or is it metabolic dysfunction? And that's an interesting question. However, the fact is that removing some of this iron improves health. The iron is certainly doing something there in those cases. You've read my book, and there are a wide range of health problems associated with iron. For example, Parkinson's disease. So, Parkinson's disease is associated with the death of dopaminergic neurons in a certain part of the brain. And iron seems to be involved in this. Now, of course, as I stated a little before, that we human beings, mammals, carry iron inside ferritin to keep it from reacting with other cell components and proteins and so on. So why is the iron reacting in Parkinson's disease? That's not really known, but obviously the iron has gotten out. The iron this is free iron we're talking about. It's reacting with cellular components, lipids, and proteins, and causing damage. So, iron in experimental models, iron chelation, which is removal of iron using certain drugs or chemicals, can alleviate the damage from Parkinson's disease. Why the iron gets free, that's another question. It could be, again, metabolic dysfunction. There are definitely unknowns here.
Yeah. So why do you think that it's so common that we have high ferritin levels as a population?
Yes, very good question. So we human beings and mammals, we have ways of regulating iron absorption. So there's iron in the food that we eat as required element, and we absorb it. And if everything is working properly, we can fine-tune how much we absorb from our food. So if we have adequate iron and we're generally healthy, we will decrease the amount of iron that we absorb from food. Now, if we have metabolic dysfunction of some kind, that mechanism may be overridden. And I should say also for the viewers here that we have no mechanism of getting rid of iron. So when we continually absorb more iron than is good for us, it just accumulates. So in the past, this was not so much of a problem. We didn't necessarily evolve in a high iron environment. And certainly since the advent of agriculture, when we've eaten less iron-rich foods, it was just never a problem. Women do not have as much until middle age, till advanced middle age, women do not have as much of a problem with iron as men, because they're fertile and they go through a menstrual cycle every month and they lose blood. Blood is the most iron-rich part of the body. Also, until recently, in a more of a state of nature, human beings had more intestinal parasites. They would have bled from wounds and accidents, for example. And furthermore, most of the problem with excess iron happens beyond middle age. So if not that many people are living beyond middle age, then it's less of a problem. So why now? So there are all these factors. People are living longer, and the iron just accumulates longer. Also, so in the United States and many other countries, food is fortified by law with iron. So in the United States, flour and cornmeal is fortified with iron. So even if you were, let's say, a vegetarian or a vegan, even you would be getting plenty of iron from this food, from that kind of food, if you ate it. And iron is also found. People take iron supplements, and it's found in multivitamins. This way of getting iron, so basically, in both cases, in fortified food and with supplements and so on, we're basically talking about naked iron, right? That seemingly more readily bypasses iron regulatory controls. Some of the scientists who are involved in this research believe that food fortification and iron supplements and so on are perhaps the main reason why people get iron overloaded, aside from, of course, genetic problems. And so we're living longer. Iron accumulates. We're no longer going into battle and having getting wounded and bleeding and this sort of thing. For women, of course, after menopause, their health becomes worse, and it is, it coincides with having higher body iron stores. So for all those reasons, many people, maybe most people who are of middle age or higher have more iron than is good for their health.
Yeah. You mentioned that we have no function of getting rid of it, but you also mentioned that paper where they used chelators. Are there any such ones that we can get our hands on if we want to go out shopping?
I'm sorry, I didn't quite understand the last part of the question.
The iron chelators that we can take to get rid of iron. Can we find them in a health store or?
Right. So there are a number of substances that chelate iron, and interestingly enough, a lot of them. This is part of the more or less indirect evidence about iron and health. A lot of these substances have been studied for their health effects, and they turn out to chelate iron, to grab on iron and remove it from the body, or to prevent its absorption. For example, curcumin. So curcumin has been widely studied as an anti-cancer drug, for example. It has been used in traditional Indian medicine and so on, and it strongly chelates iron. Now, whether that is solely responsible for its effects, well, we certainly couldn't say now. I mean, it seems to do a lot of things, but that is one of them. If you give mice curcumin in their diet, for a long period of time, they become iron deficient. So there are things like curcumin there and various other polyphenols that, again, they're widely thought to have beneficial health effects. For example, the polyphenols in tea and coffee. So green tea, of course, has been widely studied for its health effects. Black tea also seems to have very similar order of magnitude health effects as green tea. And they have chemicals in them that hinder iron absorption. So for example, if somebody drinks coffee or tea with a meal, then their iron absorption will be hindered. And in fact, in less developed countries, iron deficiency is more of a problem than in the developed world. And drinking of tea has been studied as the problem for this very reason, is that there's a lot of tea drinking going on in some of these places, India, for example, China. And when people are drinking tea more or less constantly or with their meals, they don't absorb iron as well. So there are a number of things like this. There are also drugs that chelate iron that are used in situations of iron overload. So yeah, those are all out there.
Okay, cool. So what do you think about the RDIs for iron? Are they correct? Do they need to change? What's your take on it?
Well, they may be okay. The problem is excess iron accumulation, and and possibly exceeding the RDIs. So, for example, in the United States, adult men, the RDI, RDA for iron is 9 milligrams a day, I believe. And for women, it's approximately double. I'm not sure about those numbers at the moment. I'd have to look that up. But
something like that.
So for men, for example, and for postmenopausal women, the average loss of iron in a day is just in the range of 1 milligram. So conceivably, if somebody was getting more than 1 milligram a day, then gradually the iron would accumulate. So I guess I hope that answers the question. Yes, if they get more iron than the body can use, then they would accumulate iron. If they are absorbing all that iron, whether the recommended daily amount for iron is too high or too low, I'll be agnostic on that one.
I guess that totally depends on how you function metabolically and if you're going to absorb it.
Right. Yes, yeah. It would.
So jumping again over to the thing that I was most interested in here is the correlation or association between high ferritin levels and insulin resistance. And do you want to just jump into that and tell us a little bit about what you know about that topic?
Sure. Well, so yes, ferritin is associated with insulin resistance, and there have been, again, studies showing, experimental studies showing that if you remove some of the iron, then this insulin resistance goes down. In fact, even most of these that I've seen have to do with phlebotomy, removal of blood. But there was even one where they put people on a low iron diet, and they had them drinking either coffee or tea at every meal or red wine with dinner. Red wine is another one that hinders iron absorption. And they got their iron down and their insulin resistance went down. And so, again, here's a case of, which came first. Was it the iron or was it the insulin resistance? Iron certainly seems to be involved in some of the bad things going on there. One of the things going on with ferritin seems to be that when people have high blood sugar, then proteins in the body can become glycated, and when they do become glycated, they don't function as well. And ferritin is a protein, and it can become glycated, and then unable to hold on to the iron in it, and then therefore free iron becomes loose and reacts with surrounding biomolecules and causing damage and problems. Now, the interesting thing is that in all cases that I'm aware of, any kind of damage going on is due to free iron. So, in theory, if somebody had a high ferritin, but everything was just perfectly controlled, then there wouldn't be a problem. But in practice, as I made the analogy in my book that ferritin was like dynamite. So, dynamite, you store it. It's supposed to be all very safe and everything. You don't want to get it too close to a flame and so on. But you really don't want to store dynamite in your house. It's asking for trouble. So you could look at a high ferritin in this way. In practice, there's always going to be some amount of free iron. In metabolic dysfunction, like in insulin resistance, there may be a lot more free iron. So in practice, by keeping your ferritin level in the low normal range, you minimize that chance of having a lot of free iron around.
Okay. So you think that it's mainly a problem? What I'm asking is literally the chicken and the egg again. So it sounds like when you have a lot of ferritin, that could be damaged by high blood glucose, literally. But on the other hand, if you have a lot of free iron, could that cause insulin resistance, do you think, on its own?
Right, exactly. Well, you get this chicken and egg problem. Certainly free iron, I mean, in experimental studies, whether they're animal studies or cell culture studies, free iron is very damaging. For example, a common animal that aging studies are done on is the worm, C. elegans. Yes. And they find that when they chelate the iron in their media, that they live longer. And when they add iron, they have shorter lives. So this is free iron. They found that for fruit flies, when they inhibit the amount of iron that they can absorb, that they live longer. So again, this is all free iron. There's lots of evidence in these cases. But again, what comes first, whether in my opinion, if someone has a high ferritin, there's bound to be some level of free iron in the body that's causing damage. There is an interesting study, the Copenhagen City Heart Study. So this was a study of several thousand people, much like the Framingham study in the United States, and they looked at all kinds of different parameters. So one of the things they looked at was ferritin, and they found that people who had a 600 or higher ferritin, which admittedly is quite a high level, had a median age of survival of 55 years. And that as ferritin levels went down, the survival was longer. So at a ferritin level of 200, and it was also a linear function or dose dependent, let's say, function. So the higher the ferritin, the shorter the lifespan, and the lower the ferritin, the higher the lifespan. So at 200 ferritin or less, people were living, their maximum 75, I think, or something like that in this particular study. So, why that is, whether say metabolic dysfunction made them have the high ferritin, or the high ferritin made them have the metabolic dysfunction and the shorter lifespan. That's hard to say. Animal studies would seem to indicate that iron is indeed very important and causative in lifespan.
Yeah. Okay. So if I got this right, you are also eating a meat-based diet, and I think a lot of people would then be like, okay, so if we should be scared of high iron levels, shouldn't we avoid red meat?
Right. So this speaks to how metabolic function or metabolic dysfunction affects iron absorption. So I have had my ferritin checked, and it's in a range that I'm happy with, and so I don't seem to have any excess iron absorption from eating red meat. Now, there is, if you look in the literature, there is an association between higher intakes of red meat and higher ferritin levels. So that is there. But of course, if you look in the literature, you can find an association between meat and all kinds of things, often, fairly trivial associations. Certainly, somebody with hemochromatosis or hereditary iron overload might consider looking at their red meat consumption, and that is in fact what doctors tell them. However, people with hereditary hemochromatosis, they get regular phlebotomies to keep their iron levels low. And the effect of the phlebotomies is likely going to swamp any other effects of not eating very much meat. As for other people, as I was saying before, iron supplements, iron fortification, flour and cornmeal, multivitamins seem to be a much more important source of excess iron than does red meat.
Okay. So I know I keep saying this, that if you are eating carnivorous or a low carb diet that is meat heavy, probably don't need that many supplements. And if we're going to do supplements, do the ones that you know that you need. So this, but I still know that a lot of people are just kind of taking multivitamins just as an insurance. So what you're saying basically is that could go haywire, basically.
Yeah. Yes. I am not a fan of multivitamins for that reason. There actually are 3 minerals that people should not be taking unless they know they have a demonstrated need for them, and all of them are found in multivitamins. Iron is one of them, calcium is another one, and copper is another. So most multivitamins contain all 3 of these. And so, you do see now more, they have some, what do they call them? Like adult multivitamins, or, old people's multivitamins or something like that, without iron in them. But then they do have calcium and copper. If they didn't have all those things, I'm not sure how much value they would provide. I agree with your assessment that, people shouldn't be just, popping things just on the off chance that they need it. And a multivitamin is one of those things.
Yeah. So if someone goes to the doctor, they have a ferritin level of 250 nanograms per, is it deciliter that they're doing?
No, it's nanograms per deciliter, right?
Yeah. What should they do? Should they ask the doctor for phlebotomy, or what would you do?
Well, if I had a 250 ferritin, I would. I mean, I would want to do something about it. I would want to get it lower and keep it lower. So the problem is, most doctors are not going to do that. If you had hereditary hemochromatosis and your ferritin was over 1,000, yeah. In fact, I just spoke to somebody today who's doing that very thing. Just discovered he had hemochromatosis. He's getting weekly phlebotomies. But for most people, that's not an option because, again, with this normal range, for example, some normal ranges go up to 500 for men. So it's not even flagged as abnormal. And most doctors, being the way they are, they're just going to say, well, that's normal. It's not important. So there may be more what in the United States are known as functional medicine doctors or integrative medicine doctors that would be more willing to do that. Even there, I'm not so sure how common that would be. The best option is to donate blood. Donating blood is the quickest and surest way to get ferritin levels down. Rule of thumb is that every blood donation lowers ferritin levels by about 50 points. So, unfortunately, there are a lot of people who are not eligible to donate blood, so that is not an option for many people, maybe most, if you consider the entire population. So the only other option there is to use some of the things I talked about in my book. For example, if you drink tea or coffee or red wine at every meal. So presumably you'd have tea or coffee at breakfast and not red wine, but later in the day you could have red wine with your dinner. These all hinder iron absorption. Dairy products hinder iron absorption too. So there is that. If I discuss this in my book for somebody who wants more details, and there is a paper that out there about this low iron diet by Dr. Francesco Facchini, who did this study. So that is the option. There again, like we talked about, there are things like curcumin. There's another supplement called IP6, inositol hexaphosphate, that can be taken that can lower iron levels over time. These methods, like I'm talking about, do take longer than donating blood or getting a therapeutic phlebotomy.
But on the other hand, building up a storage of iron takes time as well. So I'm assuming that it's not an acute issue. We can do that over time. Most of us have some time to do that. We're not going to fall dead tomorrow because of it, I guess.
Right, for sure. Although, I've spoken to I spoke to someone else a while back who had he read my book, and I spoke to him, and he tested his ferritin, and he had 600 ferritin, and he was having various health problems. He's a middle-aged man, and he couldn't find anybody to help him out. I mean, the doctor saying, well, that's not high enough for a therapeutic phlebotomy. And I believe he eventually got around to donating blood. He was eligible to be a blood donor, and he did it that way. But it's and therapeutic phlebotomy is not well remunerated by health insurance and so on. It's a pretty low level procedure. It's why people aren't healthcare isn't really all that gung ho about it. It's not an exciting new drug or technology, and so Yeah, so it can be difficult.
Yeah. Okay, so do we do you think that everyone needs to go and test the ferritin levels, and just as an insurance to see where we're at with our health when we're aging? What do you think people should be doing, or should we pay attention to our signs and symptoms and go and check it if we feel a bit strange in some way?
I believe that adult men should at least once in a while get their ferritin checked. Men start accumulating iron after about the age of 18 or 19. Until that time in their lives, they're using it to build their bodies, they're growing and so on. But then ferritins on average start rising. So generally it isn't a problem if the man's in his 20s. But I think a man who's over 30 and especially over 40, I think it's worthwhile getting tested. I've seen too many high ferritins in people that, you know, I would say it's always a good idea. It's a relatively cheap and common test, so it's not that big of a deal to get one. Generally, doctors don't order it unless they feel like they have a fairly good reason to. But if you ask them, you know, it's also not a big deal. So you can get one. Also in the United States, it is possible to order your own lab tests in most states. So people can do it that way. Like I said, it's not expensive. For women, they would generally not need to check until after menopause. And even then, it like you said, iron accumulation is a fairly long process. So even then, it might not be necessary or advisable, let's say, until age 60 or something like that. One thing about postmenopausal women and iron is women seem to suffer ill effects at lower levels of ferritin than men do. It could be maybe that's an artifact of the fact that premenopausal women are generally in better health than men, in some cases quite a bit better, for example, with heart disease. But so certainly I would say for a woman at age 60 and up, it is worth checking ferritin, and for any man of middle age and up.
Awesome. Thank you. Do you have any final words, tips, things that you would like to share with my viewers before we wrap this up?
I would say that iron is, definitely worth looking at. As one of my main interests is in anti-aging, life extension. And as far as I can tell, based on the research, iron is a very underrated factor here. Centenarians on average have relatively low ferritin levels. And so it's based on experimental studies and animal work, it's just very interesting, the relation between iron and aging. Old animals accumulate iron, and then it causes a lot of damage. And it seems to be that if you can prevent that iron accumulation in these laboratory animals, that a lot of this damage doesn't occur, and they're in better health. Certainly, there are human diseases that appear to be very much related to iron, such as Parkinson's disease and Alzheimer's disease. Iron, give you a quick example. In Alzheimer's disease, there's been much research and discussion about what actually causes it, and so on. And some of the more interesting research that's come in the last few years has found microorganisms in the brain of Alzheimer's patients. Now, is the fact that microorganisms require iron to reproduce. And withholding iron from microorganisms is one of the human body's defenses against infection. So if you can withhold iron, then presumably these microorganisms, the fungi and bacteria that have been found in Alzheimer's brains, they've used iron to grow. So, how much of all that is causative in the case of Alzheimer's, it's, very much an ongoing research project. But as far as iron and aging, I truly believe it's one of the most underrated factors that people don't know about. So, for good health and long life, I think people should keep their iron levels, in good control.
Awesome. Thank you. And I just want to mention, do you want to tell people your age?
Sure. I'm 65.
Yeah, you don't look it. That's what I wanted to ask.
Thank you. Thank you. I work pretty hard at it, as far as my health and fitness. And so hopefully it's working.
Yeah, as far as I can tell anyway. If people want to get in contact with you, where can they easily find you?
You mentioned my website. It's roguehealthandfitness.com. So that's one place. I am very active on Twitter, and my handle on Twitter is Mangan150. And those are the two best places.
Right. I'm going to put that in the description if anyone wants to contact you. So thank you so much for coming on here today. I really enjoyed this interview. There's a lot to think about there, I think, anyway.
You're welcome, Pim. It was my pleasure. Thanks for having me.
Thank you.